Yeah, hello everyone, and a very warm welcome to the 21st edition of our 3D Thursdays webinar series. As many of you know by now, 3D printing continues to reshape industries from aerospace, automotive, healthcare, education, and the consumer products. Today, we are focusing on a very exciting topic that is built to produce, certified to deliver, on how aerospace aim lessons are rewriting the industrial playbook. This webinar primarily explores how additive manufacturing is rapidly evolving, not just from prototyping, but to an actual certified serial production for mission critical industries and parts. This webinar explores how aerospace and defense AM lessons are helping industries build scalable, production ready, and certified focused manufacturing strategies. Whether you're in aerospace, defense, automotive, energy, or space, this session will definitely provide you valuable insights into what actually it takes to move from a design intent to an actual delivered, certified, high performance metal AM parts at scale, while you have to rethink the future of industrial manufacturing through a lot of additive manufacturing techniques. We'd love for you to stay involved throughout the session. While we actually have a dedicated Q&A at the end of the session, please feel free to drop in your questions to the chat anytime during the session. We do our best to cover as many as possible and try to group quite a similar few questions together. Your interest in interaction is what makes this session very meaningful. Just a quick side note, today's webinar is being recorded for learning purposes. So when you participate in this, you agree to actually get this recorded and the distribution within our learning community. So it's time now to welcome our speaker for the day. It's my pleasure to introduce you our speaker today, Mr. Yathiraj Kasal. He's the General Manager and Business Head with Wipro 3D. Mr. Yathiraj Kasal is a seasoned professional with over 30 years of experience and currently serves as a business head with Wipro 3D. He has an extensive expertise across additive manufacturing, advanced engineering, driving innovation and industrial scale adoption for metal additive manufacturing solutions. Previously, he held leadership roles at GE Additive and Honeywell Aerospace, where he has led additive manufacturing initiatives across design, material development, industrialization, and certification of aerospace applications. He has played a very key role in establishing advanced AM facilities, scaling production programs, and supporting qualification, certification initiatives, and mission critical components. With deep expertise in design for additive manufacturing, productionization, quality systems, and lean transformation, he has successfully led several high-impact aerospace programs, including FAA certified additive parts. He's also a certified lean expert, design thinking trainer, and AM specialist with multiple patents in the field. So today we are excited to have him here to share his knowledge and experiences with us. So please help me welcoming Mr. Yathiraj Kasal for this session. Mr. Yathiraj, the session is open and it's all yours.
Thank you, Deepak. Hello, everyone, and welcome to this month's 3D Thursday. As Deepak introduced, I have spent close to 3 decades at the intersection of aerospace engineering, additive manufacturing, and industrial use of additive manufacturing in GE Additive, at Honeywell, and now here in Wipro 3D, where we run one of the India's most comprehensive end-to-end AM operations. So over the next 35 to 40 minutes, I want to take you on a journey that begins in the combustion chamber of a jet engine, basically the parts what we print for jet engine, and ends with a question that I believe is the most important strategic question for any industrial leader who is attending this webinar today. So that question is, are you AM ready? Not AM curious, not AM experimenting. I'm asking about, are you AM ready to certify, to produce, to deliver at scale? Let's get into it right now. So I have around 14 to 15 slides, and we will have a dedicated Q&A. And like Deepak was saying, please key in your questions in the chat window, and he will actually probably club them and ask me at the end of the presentation. So before I talk about how to produce parts with AM in serial production mode at scale, let me explain why you or anyone cannot afford to wait any further. So there are 3 forces which are converging right now, and together they make this the most important moment in Indian industrial history for AM. So the first thing, you would have seen because of the pandemic or the war situation, geopolitical, the supply chain fragility. So the pandemic, during 2020 and 21, it really exposed brutal truth about how it's being underlined by which is being now underlined by geopolitical situations on how we were dependent on the global supply chain. So there were many cases, even including our own operations in Wipro 3D, where we had to wait for 60 weeks to procure certain things. So the parts which are taking 60 weeks to procure through traditional channels can bring an entire production line to its knees. So AM can actually print those same parts in under a week and machine them further to take them to fully finished stage in 2 to 4 weeks. So total around, I would say 3 to 6 weeks, you will be able to get a part which actually takes around 60 weeks. So there is a well-researched article by one Mr. Arthur D. Little. The website is called ADL, who documented cases where components typically were taking 60 weeks were produced in 1 week via AM. 1 week is basically the printing, but like I mentioned before, it takes another 2 to 4 weeks to finish it. So whether it is oil and gas, defense, or even energy operators for that matter of fact, so where the downtime costs millions per hour, that's not AM is not a benefit there. It's actually a lifeline for you. So second is the second major factor what you have to consider, what all of us have to consider is the India's indigenization effort. Basically the Make in India or Atmanirbhar Bharat, and many more are there. So the government has published what government refers it as Positive Indigenization List, PIL. So there is a list of parts which has been published openly. DAP 2020, Srijan, IDEX Aditi program. So these are not just policy documents, they are the purchase commitments from the government. So these are the licensing windows from the government. So procurement guarantees and domestically manufactured parts. So we need to see how we can actually leverage what is available in front of us in India today. So AM is the fastest path to qualifying and producing those parts locally. We have seen it, and like me and Deepak were referring earlier, I have seen it firsthand, whether in my previous organizations or here, how AM can really address the supply chain issues. So the third factor which we want to highlight today is the competitive disruption. So basically, you cannot afford to wait and watch. So research estimates, these are not the numbers what we are making up. So there is a reference behind each of the numbers what we are quoting here. So research estimates that AM has helped actually close to $113 billion in global manufacturing savings. So this is not the revenue, this is the savings in just 2025. So, we keep hearing about the parts which are lighter, where we are combining parts, where the efficiency is improved. So organizations have realized 113 billion savings just in the year 2025. And global AM market, if you talk about the revenue, it's around 14 billion US dollar. And India's own AM market, which includes machine sale, material sale, part production, services, everything included, it's projected to grow at 26% annually. So it's an unprecedented number which you cannot expect in any other market other than probably AI, which we are seeing today, right? So aerospace and defense alone accounts, only those accounts accounts for almost 32% of India's current metal AM market, which means that the others have actually not adapted to the extent they should adopt. So it is still a gap for us and for you to really come together and get the benefit which AM is delivering. And it has already demonstrated in the fields like the aerospace or defense and things like that. So your competitors are already definitely trying AM and they are evaluating. If you are only evaluating, the gap is already widening. You are basically losing out on the opportunity. So I want to highlight today that the window is still open in India. We have not yet gone past that particular milestone. The question today, what you and me have to really answer is whether you are walking through it, the window which is open or not. So let me show you something that might be a little uncomfortable, but only when we actually answer these uncomfortable questions, we will be at the juncture where we will be identifying an opportunity and really going down that particular path. So there are two boxes here. On the left, you have AM Curious, basically where you are printing prototypes that impress, or you may have a printer in an R&D lab. You might have printed a proof of concept that everyone gets excited. Okay, I have printed a 3D printed part. This is the first part in my company, and we might have got given awards and things like that, and then nothing. So no certified process, no certification plan, no qualified material chain, no serial production plan. Cost per part 10 times what's commercially viable, and that is where you would have stopped. On the right side, you have what I am calling as AM ready, where you have parts which are certified, locked, controlled, and cost competitive. And critically, most critical for a batch production, these are repeatable. Batch 1 output equals batch 100, right? So research consistently shows that fewer than 15% of AM pilots make through this transition. 85% of the projects or effort stop somewhere between these two boxes, between the AM curious and AM ready. So either the interest goes off, or there is a leadership change, something happens, and basically the effort and the initiative is thrown under the rug, and you move on with your conventional stuff. So the gap actually between these two states, what I'm calling as AM curious and AM ready, is not about the machine. Very frankly, the machines are world class. Whether you are running either a US machine, Nikon SLM machine, or even a Colibrium machine, or whatever it is, the gap about the system around the machine, the process qualification, the material science, the process, the post-processing chain, the inspection protocol, and the certification pathway, this is where the gap is, not with the machine. And that is exactly the terrain I'm really going to walk you through today. And that terrain, we are very happy and proud that Wipro 3D has really navigated very well with quite a few customers today across aviation, defense, energy, oil and gas, even semiconductor equipment manufacturers. And I cannot forget, on the top of the list, not at the bottom of the list, space, right? We have so many parts which have been either qualified or getting into serial production and things like that. So, like the title we were saying, we want to see what is the lessons from aerospace and defense, and we want to adopt it for the industrial and other industries where AM is still not adopted to the extent what it should. So aerospace is where AM literally earns the stripes and stars, right? So many applications manufactured through AM have been certified as airworthy across companies, across various countries. We can list the components, and we can go on and on. I will show some of the components at the later point of time. So think about what aerospace demands. Parts that can operate at the temperatures which are more than 1400 degrees Celsius. If you are talking about a turbine blade, which sits right after the combustor, the 1400 degrees Celsius is a reality. It has to tolerate that. And the tolerances measured in microns, the aerospace, any components for that matter, the tolerances are very critical. Hardware, the aerospace hardware, basically, they cannot fail. Not in testing, not in service, never actually. Even in field, I just can't expect, right? A turbine blade failure, which is flying at a 30,000 feet altitude, it doesn't produce a warranty claim. It actually produces my favorite series, basically, air crash investigation, very frankly. If you have a failure, it's a case for air crash investigation series and nothing less than that. All right. So in this environment, I have personally seen, whether in my GE days or in Honeywell days, I have been part of the projects and efforts which resulted in certified AM parts, either under FAA regulation and framework. In India, it is SEMILAC and RCMA framework, and everything must happen as per AS9100D all over the place internationally, right? So I worked through every layer of the qualification stack, from raw powder characterization through the first article inspection sign off, and so on and so forth. In fact, I do have some patents. Since it is patent, it's a public knowledge. We have patented in my Honeywell days flow restrictor, containment systems, and even some for the industrial purpose, even the metal core boxes. So I know what it means when you get it wrong, right? And there is no scope for you to get anything wrong. And if AM has proven in that kind of a ground, I would say anybody can actually, with their eyes closed, they can trust on AM and implement it in their industry. And what I learned is this: the three disciplines on this slide are not aerospace problems. They are additive manufacturing problems that aerospace actually forces everyone to solve correctly. So there is a clear lessons which are available in front of us, right? So first is the DFAM, design for additive manufacturing. Typically, everybody, all of us, including me, initially I thought when we say DFAM, it is the topology optimization, but it is not just the topology optimization, right? So it is the most underestimated element, I would say. So I have watched organizations spend months printing a component only to discover that the design was never right for the AM process, right? Either wrong support strategy, wrong wall thickness, unmanaged residual stress, um, so on and so forth. The machine, like I mentioned earlier, the machine is perfect. It's only that we have not designed, oriented, supported it well. So hence the design would fail it, or build will fail, right? So we blame that, okay, AM is not ready kind of a thing, but it is up to us on how to make it work. It takes some experience and some expert guidance and some patience when you are actually giving an opportunity to the new technology like what we are speaking today. So aerospace, what it taught us, I mean, you solve a DFAM before you press print, right? Every single time. And the AM crucible of aerospace, the zero fault tolerance, the multi-layer certification, the DFAM discipline, that's the foundation of everything I'm going to share with you today. If AM process is working in aerospace, it should and will work anywhere, right? So the reverse is not true. Yeah, I'm on the fourth slide on the serial production. Deepak, just confirmation. Guys, I'm actually joining from a different place. You are on the serial production playbook, right?
Correct. You're right, Ati. We're all on the same.
Thanks for confirmation. So the title of the presentation today is Build to Produce, right? What does it actually mean in practice? And it has been proven in aerospace. It means these five levers, which I'm showing there, all these levers are qualified, validated, and most importantly, locked and simultaneously. Simultaneously, in the sense, all these five levers have to lock simultaneously. So let me take you through each one of these lessons, what I have gathered while working on various projects. First and foremost, material. You need a certified powder with full traceability, right? What do I mean by traceability? Lot number, batch date, storage conditions, recycling cycles, again, so on and so forth. So I have seen lot to lot variation. I mean, we may feel that, okay, everything is procured under the same specification. So what's the big deal, right? But we have seen a lot to lot variation in metal powder is real, measurable, and it has an influence on the mechanical properties. So, this effort was studied before I joined GE, but it was there available for all of us to really understand and appreciate. So GE Aerospace, they were the pioneers in adopting the technology by any measure. So they learned this at scale, powder management, how to do it. So what I would say is powder management is not a procurement function, it's a quality function. And only when you have this quality mindset, when you are dealing with all the elements, only and only then you'll be able to produce the parts and make them airworthy and put them in flight. Second one is machine, right? Which is basically the building platform. Platform is not the build platform. What I mean is the machine as a platform, as a technology rather, right? It must be qualified, not just operational. I mean, if you are switching on, if it is turning the laser on, that doesn't mean anything. I mean, the machine has to be qualified. Qualification means the thermal mapping across the entire the build plate or build chamber, documented purity, calibrated laser parameters, formal records of everything. An unqualified machine is a development asset, is what I can say, not a production asset. So qualification is very, very important when it comes to the machine aspect, if you want to really get into the production kind of a scenario. So once you have the material which is qualified, the machine which is qualified, then comes the parameter or the recipe of how you print, how you convert this powder material into the solid material using the LPBF as a process, right? So my experience has been on LPBF at large. So once your process parameters are locked, they are locked. You don't change it. If you make a parameter change after the qualification is done, you're not just updating the qualification, you basically restart it. Right. So the discipline is brutal, ruthless, and it has to be that way because in aerospace, at least, you're putting these 250, 300 people at 30,000 feet, and you can't take chance with that, right? So it's a non-negotiable in aerospace and increasingly in defense and energy as well, because even here you are having assets which are worth crores. Life, which is, basically you cannot tie a value to that, right? So then comes the post process. You have the powder, you have the machine, which you have the parameter, which are all locked. Now comes the post process. So this is where I have literally seen that the most underestimation happens. Heat treatment, surface finishing, chemical processing, machining. Each of these steps must be qualified as part of the overall process chain, right? We are not just printing and putting them on the flight. You are actually finishing them, right? Only then you are meeting the part to the 2D drawing or the print, and only then you can qualify the part. So the AM part is not certified part until every step of the post processing has been validated, right? So post process is where the metal actually becomes the component, a component which can be fielded, which can be put on the aircraft, which can be put on the asset, which can be put on the oil rig. And then comes inspection. Again, we don't focus too much on post-process and inspection. I really want all of you to take a note of it. On this is equally important, if not more. It is as important as the first three parameters itself. Whether it is CT scanning, NDT, CMM verification, and critically closing the loop, feedback loop, basically into every build. So inspection is not a final gate. If there is an anomaly which you are detecting in the inspection, you should feed it back into the process control system to make sure that you are improving your process. It could be AM, it could be parameter, it could be post processing, but you do this before actually locking everything. Like I mentioned, once you lock everything, you don't touch it, right? Because it is a production system right now. So you miss any of these five and you don't have a serial production. You cannot afford to miss any of these things. So you have a expensive, sophisticated experimentation if you are not doing this. That's all I would say. So all five must lock together. This is the playbook. So the next slide, like I mentioned, actually I have very few pictures today, probably this slide and next slide. Otherwise, I just wanted to explain my experiences and really take questions and give you the framework on how you can implement, how you can adopt this playbook, and how you can actually critically evaluate on where you are standing right now and how you can get onto the journey, right? So let me be a little concrete. The playbook which I described in the previous slide, here is what it produces in the real world, right? So GE Aerospace, by an estimate, I mean, they have not revealed the number. So last time in 2015, they revealed 100,000 LEAP fuel nozzles were produced. I'm 100% sure in the last 10 years, there is many more. I mean, my personal estimation is the number would have actually crossed 200,000, but on a conservative side, definitely 150,000 LEAP fuel nozzles are in service. So these LEAP fuel nozzles are a big deal for two reasons. So this was the first critical part to actually be certified as a airworthy. And that kind of changed the game for metal additive manufacturing from that point onwards, even for GE and for the world for that matter. So the GE LEAP fuel nozzle, if you have not come across this example, so this is 20 components which has been printed as a single component, which is 25% lighter, 15% more fuel efficient. There is a, good enough literature on this. If you just Google GE leak fuel nozzle, you will get literally a ton of information on this particular thing. And this is not a prototype story, right? I mean, I'm telling you, I mean, 150,000 or 200,000, it's a big deal. Every LEAP engine which is flying today, it's flying with a 3D printed, additively manufactured fuel nozzle. And that's the manufacturing story I really want all of you to take note. And come to Airbus. So they have 200,000, not sorry, no, not 20,000, 200,000 certified polymer parts in active service across various aircraft programs, whether it is A320, A350, and you can say whatever it is. So, I mean, this is again public information. You can cross-check it. More than 25,000 parts are printed annually. I'm referring here on the polymer parts, of course. But 25,000 parts are printed annually, and they are in service, right? It speaks a volume on how the technology has been adopted and how reliable is the technology, and how the giants like Airbus, GE, or Boeing, they're trusting the technology, right? So the 43% weight reduction, cutting the lead time by 85%. Again, all of these numbers you would have read, but these are real numbers which you cannot afford to ignore. Coming to space, Rocket Lab, they are probably one of the few companies in the world who have 3D printed the engines and even using it in commercial launches already, right? So I mean, there are around Boeing themselves have qualified multiple parts for them, and they are using the parts already in the commercial launches. And come to US Department of Defense, they spend almost 800 million on AM. At least this was a FY 2024 information, and which was already 166% increase year over year on the defense spend on additive manufacturing, right? So, well, I mean, when you see a trend which is like 166%, I mean, it is more than double the spend. You can think how it is benefiting them. I mean, if it is not benefiting, then the program or the initiative would have got shelved, if not the budget reduction, right? So if they're increasing it, they're seeing value, right? That is a clear indicator on why AM actually delivers good parts. And coming back to our own backyard in India, whether it is, I mean, in India, actually, this is our own experience. I mean, example, what I have quoted here, Wipro 3D, what enabled for HAL engines, Semilac certified part. This is a critical turboshaft engine part, which is put on Chetak and Cheetah helicopter. This was the first part to receive the airworthiness certification from Semilac. And from the last 2 years, this part is in serial production at Wipro 3D. I mean, if you come any day, if you walk into Wipro 3D, me or my colleagues will be really happy to show you how we are actually doing the serial production of this particular part. You can see it live. One of the machines is dedicated just to print this particular part day in, day out, 24/7, 365 days. I mean, the machines are built in such a way that they don't have to rest until unless the maintenance is required. Apart from the maintenance requirement, the machines run 24/7 bar 365 actually. So the proof is there. The question is not whether the AM works. I have given you enough examples here. The question is whether your organization is ready to work with AM or not, right? That is the question you have to really ask. So those were mostly examples. Yeah, the last example was the India example, HAL engines and Wipro 3D jointly. But I also want to take a moment and show you the cross section of parts here. So here in India at Wipro 3D, in the last 14 years or so, we have printed more than 250,000 metal parts. I mean, they constitute of prototypes, tools, end-use parts, and even the serial production parts like the inner ring, right? So all of those things are there. It's a journey. we engage with our customers to identify the right part and then actually transition them successfully into serial production. So working with customers and certifying authorities shoulder to shoulder to get the parts qualified and to get them into, approve them and get them into serial production. So we today we have more than 30 parts which are approved for serial production, and this is across industry verticals, not just in aerospace. So we have parts in energy customers, with energy customers, oil and gas customers, aerospace customers, space customers, industrial customers, even semiconductor equipment manufacturers. We don't print them just because they can be printed, right? Every part which you are seeing on this screen has a reason why it was transitioned to AM from conventional. And our focus and purpose has been to help our customers adopt additive manufacturing and profitably. That is the word which I really want to underline. All right. So we want to make sure AM actually adds value to make the parts or systems lighter, safer, faster, or just better than the previous ones. So here is the thing about aerospace AIM playbook, right? It's not proprietary to aerospace. Every lesson what the aerospace has, helped us understand, the lessons can be transferred directly. So let me walk you with each of the industries which I am listing here, right? So defense is the most significant opportunity in India right now. So, which is why I've actually highlighted it. So, may it be containerized AM unit, we call it as CAMU, basically where we can deploy these units for Army, Navy, Air Force to produce the certified parts in the field where they are actually required. Reverse engineering obsolete components that no original supplier are still providing or supplying. I mean, assets are waiting for parts. We have seen it firsthand. They wait for sometimes even years together, right? A direct policy alignment with, like I mentioned earlier, SRIGEN, IDEX, PIL, all of those things. So defense is really a great opportunity in India today, and Wipro 3D is very actively operating in this particular space. Automotive is taking the DFAM model for lightweighted structural components, complex tooling, prototypes, reducing the weight at the vehicle level, right? Eliminating the cost of producing tooling or even low volume variant. Especially with the rise in EV adoption, both in four-wheeler, two-wheeler, it is actually opening new fronts for additive manufacturing. Tied with the reduction in the weight of components, which directly translates to the range extension of the vehicle itself. So it's a very appropriate opportunity, even in automotive, actually, very frankly. And space perhaps is the most exciting frontier in India right now, consolidating rocket components from more than 20 part assemblies. Each of these sub-assemblies are again assemblies of hundreds of components actually. I'm only talking about sub-assemblies getting into monolith, to a single printed structure or monolith. So we have worked with ISRO, Agnikul, Skyroot Aerospace, and all of them have tested these 3D printed engines and various other components to their satisfaction with their expert committees. And there have been no problems with that. And many success stories, time and again, we have been publishing on either LinkedIn, social media, even in the news media. You search for 3D printed engine with a combination of any of the names what I'm showing here, ISRO, Agnikul, Skyroot, Wipro 3D, you will see a good positive story there. And coming to oil and gas downhole tools, valve components, impellers, pressure-rated components, we can print in days, definitely not in months. There have been so many cases where we send the proposal, we get the PO, we deliver everything probably within the same month, right? So these are very critical when the offshore platform is idle. I mean, when the offshore platform is idle, you are losing money, revenue, right? If you get the parts, you can actually get your operations running again. So the energy has been a new sector where we are seeing a lot of traction. Turbine hot section components, burner tapes, heat exchanger components. These things are helping them to reduce the overall cost and downtime in the power generation industry. And MRO, that's another story altogether. I mean, I would say this is a kind of a slipper category right now. The, the concept of digital inventory, where you don't hold physical stock of low frequency critical spares, you hold a qualified digital file and print on demand in a cloud or a common repository. This, I mean, you will print it on demand. That is how it really works. And this is actually transforming the sustainment economics, what I call it, across every industry, and definitely for MRO, energy, and oil and gas. More than, I mean, more than any industry in energy, oil and gas, and MRO, it's a sustainment economics, right? So coming to the framework, this is the framework I want you to take away from today's session. 5 stages, right? Every organization, regardless of industry or starting point, you have to navigate all 5 stages, right? Uh, most of the companies or organization which get started on additive, they never get past stage 2, frankly speaking, and that is where we see most of the initiatives falling apart. And that is exactly where the stage 3 and onwards, that is exactly where Wipro 3D's most intensive partnership can happen and work can actually begin along with us. So let me talk you through each stage and give you a kind of diagnostic question. I've noted some 5 questions on each of these things. I'm calling it as a diagnostic question that tells you exactly where you and your organizations are. So stage 1 is like you're saying, aware, right? So organization, when I'm saying you, don't take it personally. When I say you, it's basically your organization. The organization knows that AM actually exists. You have seen demos. Maybe you have a printer in, like I mentioned, in R&D lab or engineering center. Somewhere you have a printer, metal, polymer, whatever it is. The diagnostic question here is: are you printing parts or only printing props? Right? If you are not using them in field, they are nothing more than a prop for you. If no one has asked, how does this reach certification or serial production in your organization? You are basically in stage 1. So stage 2 is what I call as assess, right? So you have moved beyond the curiosity into evaluation. You are benchmarking, let's say, technologies, various technologies, and you are actively selecting candidate parts, modeling return on investment, running some DFAM assessment. You are in the right path, very frankly. The diagnostic question is: have you identified your first 3 production ready part candidates with a defined pathway from print to certified delivery, which I showed in the previous slide, right? So if you are answering yes, you are in the assess phase. The stage 3 is basically the qualify phase, which is very, very important. And this is the place where most of the initiatives actually fail. And very frankly, if you are addressing this particular thing, if you are enduring this particular stage and crossing this particular stage, you will make the AM journey successful in your organization. I'm 100% sure the crossing this stage 3 will actually give you so many success points, which will help you identify many more cases, and AM will start delivering value to you and your organization, your team, your group, right? This is where real commitment begins. The stage 3, qualify. Material qualification, machine qualification, first article inspection, certification pathway mapping. The diagnostic question here is: do you have a qualified, documented, I would say even auditable combination of material, machine, process parameters, basically all the things which I mentioned in the previous slide? If the answer is we are working on it, you are not yet qualified, but I would say you are on the right path. All right. The stage 4 is basically the scale. This is where the organization will start seeing the ROI, I would say. right? This is the stage 1, 2, 3 is basically the investment, and 3, 4, and 5, sorry, is where the ROI or the benefit will start. Trickling in. I would say serial production, stage 4, scale, serial production, right? So process windows are all logged. Statistical process control is running. Post process chain end to end, not just printing. End to end. When I say post processing quality, end to end, it is qualified and locked. Supply chain for powder, gas, consumable is secure. The diagnostic question is, can you reproduce batch 1 quality in batch 100, right? Batch 1 quality in batch 100, it should be the same. That is when you will gain confidence in the locked process. With the same machine, same material, same operator, 6 months later, will it produce the same component, right? That is a critical question to ask. And then the last stage is basically the sustain, right? So this is where AM is a competitive advantage for your organization versus your competition in the market. So you have the closed loop monitoring, which I explained in the previous slide, an internal center of excellence with trained practitioner, ecosystem partnership where that give you supply chain resilience, digital inventory if it is appropriate for you, that replaces the physical stock for critical spares. The diagnostic question here is, do you have a system that improves itself, or where you are, right? Here is the honest truth I would say, which is most important, right? Somewhere between stage 1 and 2, that is where typically the organizations fail. And if you are crossing 3, you are big way into the gains which you are going to get in the stage 4 and 5. So we need to walk this path along with a manufacturer and a certifying body or panel. A question I get asked constantly is, what's the ROI? Let me answer it very directly. Lead time. Parts that take 40 to 60 weeks through traditional supply chains, procurement, tooling, casting, machining, inspection, if they can be produced in 4 to 6 weeks, that's the operational continuity, not a cost saving for you. And then the part consolidation, like the GE leaf fuel nozzle example, or the rocket engine, which I showed you, where you are having the design for freedom for AM, internal cooling channels, complex geometries, all of these things. The value is not just in reducing the part count, but it is actually the performance which you are going to unlock for yourself. And that is the competitive edge which I explained in the previous slide. The manufacturing cost, again, the research has shown, mainly from NIST, 36 to 46% lower than the traditional methods at optimal build utilization. I mean, if you're not optimizing your build for production kind of a scenario, then you are underutilizing the technology. Once you optimize everything, NIST says they have seen around 36 to 46% cost reduction, measurable, right? And inventory economics, like I mentioned, the digital inventory. Right. There is a classic case which ADL had published, where there was like every blade was saving around $658 US, and which has a life cycle of 10 years. With 90%, more than 90% reduction in excess inventory and things like that. So when you add all of these 4 dimensions together, lead time, part performance, manufacturing cost, inventory economics, the business the business case for AM serial production is very, very compelling. In almost every industry what we have served, which I mentioned in the previous slides. So let me just pace it up a bit. I know we are around 3:43 now. So let me take a moment to be very direct on what Wipro 3D really does, because we are not a company that only advises on AM. We are a company that actually delivers it. We have delivered 250,000 parts which are in use for more than 450 customers. We are the only company who have AS9100, API 20 years, NADCAP accreditation, which are all critical elements for your serial production case. Right? We are not I would say, though we do prototyping, we are not just a prototyping company. We are a serial production AM company, right? And we deal with mainly 3 things: print services, where we have the process mapped for serial production, right from printing, heat treatment, surface treatment, NDT, CMM, CT scanning, whatever it is. We will make sure that the entire process is well established, certified, and qualified to produce the parts at scale. Right. And then we also do machine sales. we help. I mean, if you want to have a captive facility, we are more than happy to provide a captive facility. We provide installation, process transfer, process establishment and transfer, and even training to make your team self-sufficient. The consulting training, not many companies have done it, and probably we are the first ones in India to do the consulting and training arm, where we run our own AM readiness assessment. So to tell you exactly which are the where you are on those 5 stages which I just mentioned, and happy to help you with identifying the production ready parts, map it to the certification pathway, and if required, even build your internal COE for that matter. So whatever stage you are in your journey, aware to sustain the stages which I showed you, we have a service designed to move you forward on your journey. So we are close to the end of this webinar, and I want to be very specific about what I'm asking you to do. Not just think about AM, not explore possibilities, definitely not. I'm asking you to take one of these 3 concrete actions. Action 1, request your AM readiness assessment to Wipro 3D, of course. This is a structured 90-minute session, no obligation, no sales pitch, where my team, we have a dedicated team. We will come to your organization. We will assess the 5-stage framework. We identify exactly where you are, what's really blocking you from the AM adoption, which parts in your portfolio can be production ready for AM right now. You can email me directly, or even there is a general email ID which I will show you in the next chart, and we will get in touch with you, and we really want to help you. That is action 1. Action 2 is identify at least one part to qualify this quarter, not a prototype. I mean, prototype you can definitely print, and I'm confidently telling you, I mean, if you give me the component, I'll give a prototype for you. So a production intent component is what I'm asking you. So that you currently procure from your external supplier through conventional, which has lead time or cost problem or any other sourcing problem. That could be, I mean, we are happy to tell you that we will identify that part which will be AM produced and certified. We will not take every part, we will identify the right part. So send us the drawing, 3D model. We will run the DFAM analysis and the cost model at no charge and give you a very qualified assessment of the viability. So action 3, which is a good action for you and for us also. You please visit us in Peenya. We are in Bangalore, in the northwest part of Bangalore, Peenya. Bring your engineering team, bring your procurement leadership. We will be happy to walk the floor with you, where we produce certified parts, like I mentioned. We will be happily showing you the process, what we can show. I mean, there are certain parts which we cannot show for confidentiality, but there are many parts which we can show where we have the consent of the customer. And you will also see how the 5 levers, which we mentioned in the presentation, are working live in the production environment, right? CA AS 9100 our NADCAP certified facility, what it looks like from inside, not from outside. So we will take you through, and the real parts, real machines, real people, real process documentation. One of these 3 actions this week, not next quarter. Please take it, and you will definitely see the benefit of it. So the organizations that act now, 100% sure they will have a 2 to 3 year advantage over the ones who still want to be on the fence, very frankly. So this is my last slide. We have covered a lot of ground today, and I want to close with a synthesis. We started in the aerospace, the AM actually started in the aerospace crucible, the environment that forces you to get the AM right. We talked about 5 levers that must lock together in serial production. We looked at global proof points, GE, Airbus, Boeing, even HAL for that matter, and the Indian ecosystem, what we have built right now. And I gave you the 5-stage AM adoption pathway. It's a great framework to know exactly where you are and what it takes to move forward. But everything I've shared today distills into one question: are you AM ready to produce? Not to prototype, not to pilot, to produce certified, repeatable, delivered parts at scale. So I personally and my entire team with decades of experience are available to help any organizations in this session answer that question. So not with a presentation, with a structured assessment, a part review, or even walk through our production facility in Peenya. So we have a Q&A time now. Please ask us anything about the framework, the technology, the certification pathway, whatever is there on your mind, which on the AM, happy to help you. So, and if you are walking away with one thing today, let it be the diagnostic question from stage 3. Do you have a qualified, auditable, documented combination of material, machine, and process parameter? If the answer is not yet, I would say we should talk. Yeah. Thank you.